So we're going to continue talking about the celestial sphere. I looked at the videos and realized the green marker doesn't show up, so I'm not going to use green anymore. They're just going to be black, blue, and red. All right, our celestial sphere, remember, is this imaginary sphere. Yeah, that's really a sphere there. Imaginary sphere that goes around the Earth. And we're talking about these key points on the celestial sphere. The north celestial pole, the south celestial pole, and the celestial equator. Okay? Also, what we find on the celestial sphere, that is where all the stars are. And we talked about the stars being embedded in the celestial sphere. Let's talk about constellations. What are constellations? Well, I'm sure you've heard of some constellations like Orion the Hunter, or Scorpio, or Hercules, or the Big Dipper, which is not technically a constellation. Constellation is Ursa Major, the Big Bear. The Big Dipper is technically an asterism. But constellations, to astronomers, are technically regions on the celestial sphere. So when you define a position, like here's the Ursa Major up here, constellation right here, that is a region on the celestial sphere. Think of it like land on the Earth. All the land on the Earth is broken up into countries, and each of those countries specifies a certain region of land on the Earth. Same thing on the sky. A constellation specifies a specific region on the celestial sphere. Now, every culture had their own groupings of stars and their own constellations. And one of the things that's interesting to study is the differences between them. Nowadays, all astronomers have accepted the Greek constellations. Okay? The Greek constellations have become the standard for all astronomers. The advantage of that is if I say, hey, I saw a new object in Leo, a comet or something, an astronomer halfway around the world knows exactly where to look in the sky to see it, because they know what their constellation Leo is, they know what region of the celestial sphere that is. We recognize 88 constellations in the sky. Okay? Now, we're going to talk about the sun. Now the sun gets a little complicated. And the reason why is because of this. When you see here, most Earth's globes are like this. They don't have the North Pole straight up. They have it at an angle. There's a reason for this. As the Earth goes around the sun, so here's the sun, here is the Earth going around the sun in its orbit. It takes 1 year to go around once, or one revolution. As it goes around, it's rotating, right? In fact, it rotates 365 times for every one revolution. Or there's 365 1/4 days for one revolution around the sun. The thing is they realize that, well, this orbit of the Earth defines a plane, what we call the ecliptic plane. This is the orbit of the Earth. Okay? And if you go perpendicular to that, that would be straight up. But our axis of rotation, what the Earth spins on, is not straight up. Straight up would be like this. Our axis of rotation is actually tilted at an angle currently of 23.5 degrees. Now that angle changes slightly by 1/2 degree or so. 5,000 years ago it was closer to 24 degrees. Okay? And it fluctuates back and forth around 23.5. Okay? You can go all the way down to 23 and back up to 24. Currently we're in this 23.5. It kind of wobbles as it goes around. That angle there is why they make your globe like this. Okay? Now, back to the celestial sphere. This ecliptic is the orbit of the Earth going around the sun. But you got to remember, to the ancient people, they didn't know the Earth was moving around the sun. They thought the sun was going around the Earth, and it took the sun 1 year to go around. But the sun is going to follow exactly the same plane as the Earth does. Or we can say that the ecliptic is the path of the sun on the celestial sphere. And because of the nature of it, the ecliptic can be defined as the path of the sun on the celestial sphere. But notice that the angle between the celestial equator and the ecliptic is our magic 23.5 degrees. Memorize that number, all right? So there's 3 numbers you have to memorize in this whole class. 1, the speed of light, 300,000 kilometers per second. 2, the latitude of commerce, 33 degrees north. And 3, the tilt of the Earth, 23.5 degrees. If you want to sound like you're really fancy, you say the obliquity of the Earth is 23.5 degrees. But we can just call it the tilt. Works fine with me. Notice that the ecliptic here, because it's tilted 23.5 degrees, it creates 4 very specific points. These points become very important. So right here, the ecliptic and the celestial equator cross. Okay? Now the sun is moving in a path like this around the sky. Okay? And down here is when the sun reaches its lowest point in the sky, and this is when the sun reaches its highest point in the sky. Alright, so we can define each of these points. They each have names. When the sun is going from its lowest point up to its highest point, when it crosses the celestial equator, it's called the vernal equinox. And this occurs around March 22nd every year, meaning the sun will hit that point around March 22nd. Now, it's not exactly March 22nd every year. It can be the 21st or even up to the 23rd. Why? Because remember, a year is not exactly 365 days. It's 365.25. Well, those extra days add up, and then we have a leap year, and we throw in an extra day of February 29th, and that can shift it. Okay, so then shift back, it shifts to like March 21st, and then over the next 3 years, it gets closer and closer, it moves over, and then we shift it back again. So it varies year to year, but it's always around that point. All right, 6 months later, over here, we have what we call the autumnal equinox, which is September 22nd, 21st, somewhere around there. The autumnal equinox occurs when the sun is actually going lower in the sky. So it goes from its highest point to the north, and it's heading south. Both these points occur when we have an equinox. Equinox means literally equal night in Latin, which means that the day and night are exactly equal length. And on that day, on those 2 specific days of the year, it doesn't matter where you are on the Earth, well, it does, ignoring the North and South Pole. But everywhere else on the Earth, you have exactly 12 hours of daylight and 12 hours of night on those days only. Then the sun gets higher in the sky. The sun gets up here to what we call the summer solstice. This occurs around June 22nd. And over here, we get to the winter solstice. This occurs around December 22nd every year. Or you probably know that this day, on the winter solstice, in the northern hemisphere, is the shortest day of the year. We have the least amount of daylight, most amount of night. Opposite that is June 22nd, the summer solstice, when we have the maximum amount of sunlight, the least amount of night. The extreme gets higher and higher the further north you go, and I'll show you why in just a minute. All right. So, this path of the sun across the sky is called the ecliptic. Well, constellations that lie on this path, all the constellations, remember the constellations are all over the globe, the celestial sphere. The ones that lie on this ecliptic become very important because the sun passes through those constellations every year. We have a name for those. We call them the zodiac constellations. These are the constellations that the sun passes through. Each year. These are the ones you're familiar with if you've ever checked out your horoscope. And your horoscope, and it depends on what day you were born. What day you were born tells you what constellation. So these are ones like Virgo and Leo and Cancer and Taurus and Aries and Aquarius and Pisces and Capricorn and Sagittarius and Scorpio and Libra, and I'm close, but I don't know if I got all 12 of them. So originally there were 12 constellations. And when the sun was in that constellation, if that was the day you were born, where the sun was, that determined what your sign was. And then astrologers started to say, oh, well that must mean something, so everybody born in the same month must all have exactly the same personality and traits. And yeah, it doesn't really work. Not only that, is there's a problem with the zodiac constellations and the zodiac coming through it. All right, that will be on the next video.